Hello everyone. All right, welcome back to another video. I'm a little tired, but we're gonna get this going anyway. So in this video, we're gonna be talking about a very simple but powerful concept because the thing is, a lot of people kind of ignore um, the the power of this concept because computers are so fast nowadays that people don't really think about the lower level things that they need to think about. And specifically, what I'm talking about is um, one of the subtle differences between using a compiled language versus like an interpreted language, right? And why you might want to use one or the other in your production setting. Um, and to know the difference and to know at least this use case that I'm going to present is very important because nowadays people just kind of throw things over the fence, right? And they're using multiple machines in their production environment and it's costing them a lot of money. But they might have wrote this service that's running on multiple machines in one language, whereas they could have wrote it in another language and save a lot more money, right? So yeah, let's just sort of get into it. So I'm everything, like I said, is going to be done by example. So I'm not just talking just to talk. So let me show you. I wrote basically a simple program in three languages, right? So I wrote one in Golang, I wrote another in Node, and then I wrote one in Python. All right, so I'm just gonna show you sort of like how the code looks like for each of these three. All right, so we have the JavaScript one, right? Which is very simple. It's just computing the Fibonacci number, the nth Fibonacci number, right? So it's a recursive function and takes in input, and the input is coming from the command line, right? We're parsing it to an integer and then passing it to this function for it to compute the nth Fibonacci number for us. Same thing here in Python. It's the same thing. Fibonacci here. Uh, we take in the command line argument and then we print the nth Fibonacci number. Golang, same difference, right? This is taking the command line argument here and then printing out the nth Fibonacci number. So all of these are just computing the Fibonacci number. So let's look at a quick thing here on the website. So I kind of pulled up the time complexity analysis of computing the nth Fibonacci number. So if you're familiar with time complexity, this is sort of talking about the algorithm that you're implementing, right? And how this algorithm scales in regards to input, right? It could be the size of an array, or it could just be a regular input like a number, but essentially your algorithm that's running is depending on your input. So in this sense, computing the first Fibonacci number is going to take less time than computing the 100th Fibonacci number, right? And it's an exponential relationship, as you see here, right? The time complexity is O of 2 to the n. So essentially, the is going to get ugly fast, to put it like bluntly, right? Because like it's an exponential relationship. So a higher input of n is going to put more strain on the computer to compute this Fibonacci number. So essentially, what we're trying to know here is this is a very CPU intensive task, right? Because um, if you think about it, like if I drive a Ferrari and then someone else drives like a, a Hummer or something like that, if we're racing, obviously the Ferrari is going to beat the Hummer, and that's just because it has more horsepower, more just more tricks to the trade to beat the Hummer in a race. Same thing here, right? is the faster your machine, the faster it's going to compute the nth Fibonacci number, right? And in regards to the programming language, as we're going to see in a second here, compiled languages generally are faster than uh, interpreted languages. So interpreted languages are your Node, JavaScript, and Python, and many others. And the compiled languages are the Golang, like I wrote, and C and C++, these type of ones. And the reason is because your compiled language gets, we're going to look at it in a little bit, but it gets compiled into machine readable code, and it's just thrown to the machine for it to execute, right? But for interpreted languages, essentially, you can think, this might be not the best way to describe it, but you could think about it like it's getting compiled line by line, interpreted, right? I heard a very good analogy of this. It's like, say you're speaking your native language, it's going to be faster that someone on the other side knows that native language and can communicate with you, right? But what if I'm speaking through an interpreter, right? Obviously, the time back and forth between communication is going to be slower than if you can speak my native language. It's the same sort of difference. Okay, so let's look at this, and I'll talk about why this is important. All right, so what we're going to do is we're just going to time some simple runs of the Fibonacci number, computing the nth Fibonacci number. So right now, what we're going to do is just going to build this binary for the Go. Let's just call it fib, right? So it's going to run as a binary. We just compiled it, right? So if you look at it, we have an executable on the left-hand side, right here, and then we can execute it. So let's time this JavaScript one first. So let's say run it, right? Fib.js. And then let's compute the 30th Fibonacci number, right? So we see that this takes around, so we're looking at the total here, right? So this takes around 0.1 seconds to compute, or 0.2 seconds, because if you round up, right? Now let's time the Python one. So if we time this Python one and 30th, we see that it takes 1/4 of a second to compute. Now let's time the Go one. So the Go, we could just run it as an executable, right? And it actually is a little bit slower than the JavaScript one, but let's do it again, because sometimes there can be some red herrings there, right? So it's better if you do like an average run. So if you do 10 executions of the program, you get a better sense of what's happening. So you see that this is better the second time around. But let's do for higher numbers, right? So let's say node fib.js, and then we do it for 40. Obviously, you can tell this is taking a lot longer than the other one. So this is 40 for the node. Let's say Python 3. Fib.py, right? For 40, look how long this takes. And this is Python, right? So it's, I'm not even too sure why it's taking this long. But we could tell that Python was generally slower. Is it even going to finish? Okay, let's do a lower number. Let's do 32. For Python, around 32, it's already taking 1.2 seconds. So let's do for the Go executable for 40, and it takes 0.8 seconds compared to the JavaScript, which was 1.7, right? Let's run it again, and we can even run the JavaScript one again. 1.7, so it's averaging around 1.7 each run. For the Go one, it's averaging around, you see, 0.8, right? And for the Python one, man, looks like we can't even get to the 30 or the 40. Let's do maybe 34. Even for 34, look how slow it is, right? So the thing is, what I presented to y'all is these are examples of CPU bound processes, right? Where the more CPU that you dedicate to this process, the faster it will be. But the thing is, for compiled languages, it does more with less CPU, right? So the OS doesn't need to dedicate as much resources to uh, a compiled a binary or a, a binary executable that's running because generally it's faster than the interpreted one. But for interpreted, the OS needs to dedicate a little more resources for it to run faster because there's the overhead of the interpreter, right? That's reading the code line by line and interpreting it each line. So let's look at this, right? So I kind of have a nice little Stack Overflow write-up that sort of shows a little difference of the difference between code compiling and code interpreting. So code compiling, where it says doesn't execute the code, it only creates a binary platform independent code, which can be ran over and over, right? So essentially this binary can be read by the machine. Difference is, like, if you go to other machines, you're going to have to recompile because it might not be suitable for that machine to run it. Code interpreting compiles, for lack of a better term, the code line by line in memory and executes it on the fly. So it's generally slower, right? Because there's the overhead of it reading this line, translating it, executing, reading this line, translating it, executing, right? So what's a good use case? Say you are doing some asynchronous message processing, right? And the reason why you're doing this asynchronously is because it's very CPU intensive, right? Otherwise, like, say you can just do this synchronously and send responses back to the client. Obviously, in this case, you would want to use a language that's compiled, right? I don't want to say obviously because there might be use cases where you don't, but usually you want to. And the reason is, say you're running multiple processes on the same machine, right? Maybe you're tight on budget and you only have a few machines that you could use. Well, you don't want, if this is a very CPU intensive task that you're um, doing this asynchronous message processing, then and you're running multiple other processes on the machine, you don't want the OS to dedicate more resources to dedicate a lot of resources to this asynchronous message processing task, especially if it's written in like Node.js or Python, right? If you write in Golang or C or something like that, like a compiled language, then it's generally better. And the OS can recognize that, oh, this is performing well without the CPU that I need to dedicate to it. So we're just going to stick to dedicating um, this amount of CPU. Whereas, say it's written in Python and the asynchronous message processing task is really struggling, then the OS is going to recognize that and say, hey, let me dedicate more resources to it. But in turn, your other processes on that machine aren't getting the resources that it needs um, to to do whatever work it's doing. So this is a use case, right? And money, right? Everything costs money, and the machines that you have uh, in a cloud environment, right? The machines that you allocate, that all cost money. So you generally want to, from the language, the picking of the language, all the way up, you generally want to cut cost somehow, right? And a good way to cut costs is recognizing, well, first good way of cutting costs is recognizing that um, what the task that you're writing or the service that you're writing entails. And if it is going to be under a lot of stress, right? Say it's a CPU bound process. All these things that you have to recognize, and you can make the right decisions for your use case to save money in the long run. So that is a high level sort of, um, even though I presented this, Fibonacci, very trivial program, that is um, what it can do for you in the long run is to save money in a cloud environment. So that is essentially what I wanted to talk about, and just for someone to see this and to know that, okay, when we're picking the language or whatever the stack that we're going to be using, we can account for certain things that we need to account for, even from the language picking. So that's sort of what I want to talk about. Thank you for listening. I'm going to have more videos coming out. If you have suggestions, please put them down below, and then we're just going to keep it going. All right, later.